Hello everyone. Today we'll be discussing about refraction at a spherical surface. Let's start with drawing a diagram. Let's suppose we have the object here. Let's consider a incident ray from the object towards the medium. After refraction, the light ray would go in this way. Let's name these angles alpha, beta and gamma. Also, let's mark the point of incidence to be A and the point at which the principal axis cuts the spherical surface to be P. The point at which it will cut the principal axis, it will be forming an image. So with this, we have our diagram ready. If alpha, beta and gamma are small angles, we can consider that sine alpha is approximately equal to alpha, which is also approximately equal to tan alpha. And similarly, for the other two angles. From the diagram, we can say that tan alpha is equal to AP upon OP. Tan beta is equal to AP upon CP and tan gamma is equal to AP upon IP. Let's solve further. From the diagram, let's mention angle of incidence and angle of reflection. If we look closely, in triangle OCA, angle I is the extended angle. So we can say that angle alpha plus angle beta is equal to the angle of incidence, that is I. And similarly, in triangle AC and I, angle beta is the extended angle. So we can say that angle of refraction, that is R plus gamma, is equal to beta. And here we have R is equal to beta minus gamma. Now we will be using the Snell's law, that is sin I upon sin R is equal to mu2 upon mu1. Mu2 is the refractive index of the medium and mu1 is the refractive index outside the medium. Previously, we had already calculated the value of angle of incidence, that is I is equal to beta plus alpha. So let's substitute the value, and similarly R was also calculated, that was beta minus gamma, and let's put the values. We also know that for small angles, sine of alpha plus beta can be written only as alpha plus beta, and sine of beta minus gamma can also be written as only beta minus gamma. On cross multiplication, we have mu1 into alpha plus beta is equal to mu2 into beta minus gamma. On solving further, we can also substitute the value of alpha as tan alpha and the value of beta as tan beta for small angles, and we have already considered that alpha, beta and gamma are small angles. On solving further, mu1 into tan alpha, the value of tan alpha was AP upon OP, plus mu1 into tan beta, that is AP upon PC, that is equal to mu2 into tan beta, that is AP upon PC, minus mu2 into tan gamma, that is AP upon PI or IP. Cancelling out AB from both the sides. And on solving further, we have mu1 into 1 upon OP plus mu1 into 1 upon PC is equal to mu2 into 1 upon PC minus mu2 into 1 upon PI. If we look closely, OP is nothing but that is the object distance from the spherical surface. PC is the radius of curvature of the spherical surface, and Pi, that is the image distance from the point P or from the spherical surface. So let's substitute the values directly in the equation. So we can write mu1 into 1 upon u, putting OP as u, plus mu1 into 1 upon r, because PC is equal to the radius of curvature and we are considering the radius of curvature to be r. That is equal to mu2 into 1 upon r again minus mu2 into 1 upon pi, that is v, the image distance. On solving, we have mu1 upon u plus mu2 upon v equals mu2 minus mu1 upon r. And on applying sign convention, the final formula we have is mu2 upon v minus mu1 upon u is equal to mu2 minus mu1 into 1 upon r. That's it. Thank you.